Have you ever been very sick? Have you ever taken antibiotics? They might have saved your life. When antibiotics were introduced, they were like miracle drugs. It seemed they could beat almost any germ that came along. Well, we've overused these weapons. And now diseases we once thought we had conquered are making dangerous comebacks. Humans versus bacteria. Unfinished business. In 14th century Europe, 56 million people died of the Black Plague. People believed the plague was caused by poisonous gases emanating from the earth. And doctors wore these suits with flower petals in this beak, apparently believing it would protect them from the disease. Now, the idea that there are germs and that they cause disease is something we take for granted these days. But can you imagine a time when people didn't know the cause of infections, didn't know about hygiene, didn't know about germs? Some bacteria attack your cells. Some bacteria produce toxins. Some bacteria you can't live without. But when the wrong ones get inside you, they can make you sick. Sometimes sick enough to kill you. Now take a look at this. It's a graph of the mortality rate, the number of deaths per 100,000 people. This one is for infectious diseases over the last 100 years. You see, it starts out big. There are a lot of people dying of infectious diseases. We're talking about bacteria and viruses, causing diseases like pneumonia, cholera, and typhoid fever. You see, people were just becoming aware of germs and how they cause disease and how they spread. So although this graph starts out high, it is headed down. Fewer and fewer of us were dying of infectious diseases each year. That's because more municipalities got good at purifying and storing water. More and more of us got connected to high-quality sewer systems. We could wash diseases right off our hands, out of our living spaces, and down the drain. That said, take a look here in 1918. There's a huge spike. That's because 25 million people died of the Spanish flu in just 4 months. It took the 4 years of World War I to kill 25 million people. 25 million people. I mean, that's a lot of people. That's enough people to fill the stadium. Not once, not a dozen times. It would fill the stadium 400 times. And they all died in just one winter. That was one deadly disease. Well, anyway, after that, the rate of death by infectious disease started going down again as more and more of us got more sanitary. In 1928, there was a breakthrough. Penicillin was discovered. It was the first antibiotic. Now, antibiotics kill bacteria, but it wasn't until 1942, when World War II was being fought, that penicillin was manufactured in large quantities. It was the first mass-produced antibiotic drug. And we used penicillin on the battlefield, in surgery, and for routine infections at home. And sure enough, the line turns down sharply. Now, this was good. But by the 1960s, this was great. We developed all kinds of new antibiotics. It's been called the golden age of antibiotic discovery. It seemed like we had a pill that could kill almost any bug. In 1969, the Surgeon General declared, "We have won the war on infectious disease." And this turned out to be a pretty hopeful statement, because the line has started back up again. There are a few new diseases, like the human immunodeficiency virus. But also, it's partly because bacterial bugs have developed a resistance to our antibiotic drugs. These are the same drugs that used to kill them. Now, an antibiotic is a selective poison. It kills certain bacteria without harming the cells in your body. Now, different types of antibiotics affect different bacteria in different ways. But let's say this is a petri dish full of cells, and they're under attack by these blue bacteria. And this glove represents penicillin. And this type of antibiotic interferes with a bacterium's ability to construct its cell walls. So when it encounters the penicillin, the bacteria burst open and die. When you take antibiotics, the bacteria in your body will either die or they will survive, because their genes carry a mutation that makes them resistant to the drug. Now, that's how bacteria evolve resistance to antibiotics. Bacteria die or mutate, and they're mutating faster than we can come up with new drugs. That's the problem. Antibiotics don't work against viruses like common colds or the flu. They're not cure-all drugs. So pressuring your doctor to give you or your kids antibiotics when you don't need them actually does more harm than good. It's estimated that in the United States, 50 million unnecessary antibiotic prescriptions are written every year. It's misuse, abuse, and especially overuse. So for now, we have to change the way we use the antibiotics that we still have. And for the future, we have to come up with new ways to fight bacteria. Now, there are organisms that have been living on Earth fighting bacteria ever since life began. We're talking about other bacteria, germs that fight germs. Check this out. We're here with Margaret Riley, Dr. Margaret Riley, at Yale University, and you study the ecology of bacteria.
That's right.
Dr. Riley is creating a new class of antibiotic drugs, ones that will kill only the specific disease-causing bacteria and leave all your other bacteria alone. If these new drugs work, they'll help slow down antibiotic resistance.
Microbes, we have them here in single cultures, so one species at a time. But in nature, they live in communities and they interact, they communicate with each other, and a large part of that communication is fending for their own territories, their own resources.
Competing.
Competing,
biological
exactly.
warfare.
And they do it through producing these toxins that kill off their neighbors.
You guys are always making up words in biology. Bacteriocin.
Well, bacteriocins are really the name of the game in the microbial world. They're the weapon of choice.
So the bacteriocin is a toxin, and it's a toxin made by a bacterium.
That's right. They kill other bacteria, and in fact, they do it very specifically. So E. coli will produce a bacteriocin that kills other E. coli, or salmonella will kill other salmonella. So it's a very narrow spectrum, as opposed to classical antibiotics, which are broad spectrum. You take a pill, and much of the flora in your gut, the bacterial flora, are killed. And that's why they're so powerful. These toxins, bacteriocins, are narrow in who they kill. They only kill their close relatives.
Your idea is you could get just the right protein, just the right bacteriocin to attack the germ and you'd have a new class of antibiotics, right?
The microbes have the idea, and it's actually about 3.5 billion years old. The microbes say the way to win these wars is to focus very specifically on your target. Kill the bacteria that you're focused on. And so if we design novel bacteriocins that can kill each of the human pathogens, then we can use them intermittently at very low levels and avoid selecting for resistance. If it were me designing who spent money where, I'd make one against every known human pathogen and each emerging pathogen as we begin to understand them.
So these are going to mutate, right? And they're going to get away, like you just make this designer bacteriocin, they're going to mutate around that.
Well,
so you got to make a bunch of extras.
Well, we've actually been working out ways to fiddle a little bit with the protein beyond what the bacteria have done so that we can produce cocktails of these bacteriocins. And then they provide a much more difficult target for the resistance to evolve.
And so that is your master plan.
That's the master plan.
Overuse and misuse of antibiotic drugs in humans and animals could make many infectious diseases untreatable. What if I told you that humans in the United States take about 3 million pounds of antibiotics a year, but our farm animals take almost 8 times that much?
I think it's terrible.
Why?
Because I think that we are ingesting a lot of antibiotics that we're not even aware of. Now you're freaking me out. I don't want to know that.
Why do you think farmers use antibiotics?
Probably to keep disease down.
But you don't have a problem with that?
No, I don't.
You're a farmer, and so what do you...
I'm a farmer. There's pesticides, herbicides, and there are cheating chemicals in all the foods that we ingest. It's bound to cause something that's not normal in the chemistry of a human being.
What are the antibiotics really doing? They're just reassuring the people who are going to buy the meat. Taking antibiotics if you don't actually have a serious infection can cause bacteria to build up a resistance to it, and then you have a real problem.
Every year, 8 billion animals are raised for human consumption. Antibiotics have been added to their feed since the 1950s. It seemed like a good idea. The animals didn't get sick as much, so they grew faster, and that kept the cost of food down. But these are the same antibiotics doctors use to treat humans. Drugs like penicillin, bacitracin, and tetracycline are in the meat that we eat. Now, these antibiotic chemicals are not just in the meat. Where you have animals, you have animal waste, feces, manure. Food animals produce 3 trillion pounds of waste per year. 90% of it is bacteria. This waste gets stirred up into the air in the form of dust. It's wetted down and turned into fertilizer for crops, or it runs off into rivers, lakes, and oceans. We're finding antibiotics in the water supply, in the soil, and even in the air we breathe. It's a big problem, but people are making a difference. Consumers are seeking out antibiotic and hormone-free meat, and they've put pressure on huge fast food chains to stop buying meat raised with growth-promoting antibiotics. In 2003, McDonald's announced they would stop buying meat containing 24 antibiotics. See, we can change the world on a large international scale or on a smaller, more personal scale. So, Peg, you're doing all this stuff. Of course, there's these terrible germs that will kill us all, right? But
Exactly.
What can we do?
Well, the most effective thing you can do is just wash your hands.
And that's what these plates are.
That's what these plates show.
So, what have we got here?
Well, before this hand was washed, it was rubbed against one of our benches, and you can just see there's all
this one.
sorts of different bacteria. Exactly.
And then
Your
they
hand
grow.
would create the same look.
How cool.
Now, if you washed your hands,
Here's, it says, this
even
one
if you
says,
didn't have soap, you just washed.
just rinsed.
Just rinse your hands with water.
Yeah.
Look at the difference between those plates.
Far fewer bacteria
Exactly.
growing.
Then,
here,
if you washed with soap like you should, you're down to just 1 or 2.
and this says 30 seconds, half a minute.
And here's a minute.
And if you did it twice as long, there's hardly
Exactly.
anything growing there at all.
And it's not just that you want to wash your hands and get these bacteria off. You don't want to get rid of all the normal bacteria that are healthy on your skin. So you don't want to use antibiotic soap if you don't have to.
You don't want to dip your hands
There's
in
no
antibiotics.
reason to.
Yeah, just
Save
wash them off.
those tools for the doctors and nurses who really need antibiotics.
We've come to a crossroads in our fight against germs. See, we can't continue to rely on the antibiotic drugs we have now. We have got to reduce our use of antibiotics. We've got to stop taking antibiotic drugs every time we get the sniffles. We've got to stop pumping our farm animals full of them. We've got to stop using antibacterial soaps, scrubs, and wipes against germs that we could be just washing down the drain. All of these things make the problem of antibiotic drug resistance worse. They all create environments where germs can mutate and lower our quality of life. You see, we're running out of drugs to fight these bugs. But on the other hand, if we all do our part, these life-saving drugs will still be available to do the jobs they were designed to do, namely, save lives. That's our show. Thanks for watching. I'll see you next time on The Eyes of Nye.